We're going to be looking at function rules, and you're going to be looking to see which of these create geometric or arithmetic patterns. When we're talking about arithmetic patterns, that means we're adding something, the same number over and over again. And if you're talking about a geometric sequence, that means you are multiplying the same number over and over again. Let's take a look at the first example. In this one, you have the numbers 2, 4, 8, 16. Then it says, then write the next three terms. Well, because we notice that the numbers are getting bigger, we notice that they could be either you could be adding something to the numbers, or maybe you're multiplying something to the numbers. Let's pretend we didn't know we were multiplying by 2. Let's pretend you're like, well, let me try adding by 2. Because doesn't 2 plus 2 give you 4? Let's try it. You always try the next number, because if you don't, you might goof it up. So let's do 4 plus 2. 4 plus 2 is 6, not 8. Therefore, you're like, okay, for sure, we're not adding by 2. Okay, so we can just take this off because it's not adding by 2. We knew the answer was really multiplying it by 2 because there it is. But I want you to see that sometimes you might need to try going up 1 or 2 or 3 times just to make sure. So the actual sequence, it is multiplying by 2. You have 2 times 2 is 4. Remember, we always continue just to make sure. Then we continue the pattern. 4 times 2 is 8. 8 times 2 is 16. Yes, they are multiplying by 2. And that is how come we know that the next three numbers, they ask you for the next three terms, right? So the next three terms are 16 times 2 is 32. 32 times 2, 64. And 64 times 2 is 128. So these are our next three numbers. Let's go ahead and try. We're going to try a couple of these. For starters, we're going to go to A. It says 0, 15, 30, 45. Okay, the numbers are increasing. So either it's a geometric pattern where I'm multiplying, or it's an arithmetic pattern where I'm adding. Let's try looking at this from the perspective of multiplication. You know it's not going to work out because anything times 0 would give you 0. So it can be multiplication. So we're going to go to addition, right? So here we're going to go, I'm going to go up here because I don't have any room down here. I'm going to add 15 plus 15. I'm going to see if this works out for each one. 0 plus 15 is 15. 15 plus 15 is 30. So, yep, we are adding, and 30 plus 15 is 45. And so, yes, we are adding by 15. So the next number, 45 plus 15 is going to be, says, how many of these we need to do? It says, there's 3 of them, so we need 3. So anyways, 45 plus 15 is 60. We're going to do 3 of these, you guys. 3 of these to continue the pattern. Then 60 plus 15 is 75. And then 75 plus 15 is 90. Okay, let's go ahead and look at B. For B, I'm going to use a red marker. That way we distinguish them. You go from 4.5 to 4. From 4 to 3.5. And they're getting smaller, 3.5 to 3. Okay, we must be subtracting because it's definitely not division here. Okay, so we are going to be subtracting, and let us find out what we're subtracting. Notice how it goes 4.5, and now you have 4. They took away a half. Then you have 4 and you take away a half, you would get 3.5. So notice they are subtracting this by a half. That's 0.5. That's my pattern for each one. I'm going to be subtracting by a half. So if I have 3.5, then I have 3. Then 3 minus a half would be, and you can do these obviously in your head. Some of these are real simple. 2.5. Take a half from 2 and a half, and you just have 2. Take a half from 2, and you end up with 1 and a half. Okay. Let's go to letter C. And we know they're increasing, so it's either you're adding arithmetic 1 or you're multiplying, which is the geometric pattern. Okay, let's go ahead and we're going to try multiplying. Why not? We have 1 times 3 gives you 3. And then 3 times 3 gives you 9. And then, 9 times, 9 times, these are so thick, I can't even do this right. Let's try erasing it just a little bit here real quick, just so it looks a little bit normal. I'm squeezing this over. My marker needs to be a little bit thinner, honestly. Let's make that a smaller marker. Oh my gosh, so much better. There we go. 9 times 3 is 27. And so anyways, now we're about to continue the pattern, right? So 27 times 3, of course you can do your work out here because you're like, Ms. Munoz, I might not be able to do this in my head. So 27 times 3, you would work it out here. Let's just say, I'm not going to do all of these because that would just take me forever. With this little marker, it's way more frustrating to even try, but you can do it like that on the side, if that makes sense, right? So you would end up with 81. Then 81 times 3 is 243. Of course, Ms. Munoz would do the math on the outside here, but for time's sake, then we do 243 times 3 is 729, comma 729. Again, I could do the work on the outside. I just don't have room. And this one works out perfectly. For the next one, I'm not going to do this one. It's multiplying. It's the same thing. You find the pattern. Oh, it's getting larger, so I must be multiplying or I'm adding, right? If you did 3 plus 3, you get 6. But 6 plus 3 gives me 12. So it's not plus 3. It's going to be times. We're going to multiply this, okay? 3 times 2. I'm not going to do the whole thing. But it's multiplying by 2, and then you will continue the pattern. But we're going to end there because it's just more of the same thing. 24 times 2 obviously is 48. 48 times 2 is 96, and 96 times 2 is 192. However, I'm sure you could figure that out. Again, what you do first is look at the pattern. Are they multiplying? They could be subtracting. The numbers are getting smaller. They could be subtracting, right? Now, you have to find out, are they adding or multiplying, subtracting, whatever it is, and then you continue the pattern to get the next 3 numbers.